So the purpose of this video is to teach you about sequences and series. So a sequence is an ordered set of numbers, and we often use the subscript notation to define them or to describe them. So you can see example here. This is a sub 1 means the first term in the sequence, a sub 2, a sub 3, a sub 4, a sub 5, etc. All the way up to a sub n. So we use the subscript to delineate which term of the sequence is. Now sometimes you can start a sequence with a sub 1. Sometimes you can start with the initial term, which would be a sub 0. And that has to be defined by the giver of the sequences or whatever, whoever's defining it. Let me get it so you can see my head. So an example of a sequence would be like, for example, 1, 2, 3, 4, 5, ... And something like that is fairly straightforward and simple. You can see, you can tell that, you can tell what the order is. That it's just basically the, you're going up, it's listing the integers in ascending order. So to go from one term to the next, you're just adding 1. Or another example of a sequence would be, for example, 3, 6, 12, 24, ... And once again, this is just an example, but there is some kind of order to the numbers that you can possibly figure out what it is. In this case, you're starting with 3 and then doubling it each time. So the first term is 3, the second term is 3 doubled, and the third term is the second term doubled, and etc. Or you could think of this as 3 times 2 once, 3 times 2 twice, 3 times 2 3, 3 times, etc. So these are 2 examples of sequences. Let me give you one more. This is kind of a funky one. This one actually has a name. It's so cool. Maybe you've seen it before. A little bit harder to see the pattern. This is called the Fibonacci sequence. And the way it works is you start out with 1 and 1. The first term is 1 and the second term is 1. And then the third term and all the terms after that are the sum of the 2 terms before it. So notice that 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, etc. So that's called the Fibonacci sequence. So that's kind of fun. So that's the idea of sequences. So main thing that you need to know for math, for calculus 3, is you need to know the notation. So understand when we write something like this, we're talking about the subscript is giving you the term of the sequence. And when we say a sub n, we're talking about some term in the sequence. And we also need to know there's 2 types of formulas we use to describe a sequence. There is a recursive formula, and a explicit formula. And depends on the sequence. Some it's easier or harder to come up with these different types of formulas. So for example, this first one, the recursive formula basically tells you how to get from one term to the next. So the way we write the recursive formula is usually we say, well, the first term is 1, and then to get any term, we add, we take the term before it, and in this case you would add 1 to it. So you can see that any term, a sub n, all you need, you can see that a sub n minus 1 would signify the term before it, because if this is a sub 6, then this would be a sub 5 plus 1. Right? And you can look back up here. To get from one term to the next, you're always adding 1. Okay? And just to do another one real quick, this one, the recursive formula for that would be, so again, a sub 1 is 3. The first term is 3. And to get from one term to the next, it looks like you would just take a sub n, you take a sub n minus 1, and what would you do to it? Well, I'm just multiplying by 2 each time, aren't I? So this would be, oops, I guess I'll put it up front here. So it would just be 2 times a sub n minus 1. So if we were to find a sub 2 would be equal to 2 times a sub 1, which would be 3. So there's a couple of recursive formulas examples. And then if we go over here, explicit formula. Explicit formula tells you how to get any term in the sequence based on what term number it is. So for example, this one, the first one up here, would be, so a sub n is equal to what? It's equal to 1 plus 1 times n minus 1. So let's see if that makes sense. So if I'm looking for a sub 5, so that's a sub 1, a sub 2, a sub 3, a sub 4, it should be 5, right? So that means I'm going to start with 1, and I'm going to add to it 1 times 5 minus 1, which would be 4. And you notice that 1 plus 4 is 5. Now we notice in this case, that was a fancy way to do it, but really, I could have just done, I was making this too hard on myself, I could have just done n, couldn't I have? So in other words, the term of the sequence is the same as its term number. Okay. Now the second one is different. In this case, a sub n is equal to, well, we know we start with 3 and we multiply over and over again by 2. So this is going to look kind of like an exponential equation, isn't it? But how many times do we multiply by 2? Well, in the second term, right here, I've multiplied by 2 once. So that's where that n minus 1 comes from, right? So again, this would give me the term, give me any term in the sequence based on, all I'd have to know is the number. So if I want to know what the 15th term was, I would go a sub 15 is equal to 3 times 2 to the 14th power. And that would give me the 15th term. Okay? So the explicit formula gives you the term of a sequence based on knowing its term number or its position in the sequence. And the recursive formula is a formula that tells you basically how to build the sequence. It usually is, you start with an initial or a first term, and then it tells you how to go from one term to the next. Notice without this information, this wouldn't be helpful if I didn't already know the sequence. So I have to have at least one term, and then the formula tells me how to go from one term to the next. Okay, so that's the two types of formulas we use for sequence. The second part of this video is I want to talk about, there's two kind of really well-known types of sequences, and I just showed you an example of each. There's the arithmetic, which is basically a linear relationship. And then there's geometric, and that's going to have an exponential relationship. Okay, so the example up above was this first one. And we can give you some other examples, like, for example, 2, 4, 6, 8, 10, ... That would be an example of an arithmetic sequence, because notice there's a linear relationship in the sense that it's growing linearly. This goes up by 2, goes up by 2, goes up by 2, goes up by 2. So that would be considered an arithmetic sequence. So arithmetic sequence always has a common difference between terms. That's how you know it's an arithmetic sequence. So the difference, so if you subtract one term from the next, you get the same answer all the time. The characteristic of a geometric sequence is it has a common factor. So up here I'm adding or subtracting the same thing over again. Down here I'm multiplying or dividing the same thing over again. So another example would be 64, 32, 16, 8, 4, ... That would be a geometric sequence, because you are, to get from one term to the next, you're dividing by 2, or multiplying by 1/2, same thing. Okay, so we got arithmetic sequence, geometric sequence. And then the last thing I want to say is, and just briefly, is what's different about a series? Well, a series is just the terms of a sequence added up. So I could talk about, I have this sequence that looks like this. 1, 2, 3, 4, comma 7, let's say. So I could write the series. If I wanted to write a series, the series would be just all these terms added up. So the series would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And so that in this case, the series is actually just going to be a number because I can add those up. Okay, let me take a look at a couple of examples here. So here it says, write the first 5 terms of the sequence, determine whether or not the sequence is arithmetic. If it is, find the common difference. So the first 5 terms of the sequence, you can tell this is an explicit formula. So the first 5 terms, if I put 1 in there, that would be 8 plus 13, which would be 21. So the first term of the sequence would be, would be, what did I say, 21? The next one would be plus 13, which would be 34. The next one plus 13 would be 47. The next one would be 60. And the fifth one would be 73. So then it says determine whether or not the sequence is arithmetic. There's 2 ways we can tell this is arithmetic. The difference between each one of these is 13, because I can tell from that I'm adding 13 each time. Or if I look at the explicit formula, I can tell it's a linear equation. And that also tells me that this is a arithmetic sequence. Okay. And let's do one more for fun. This one would be, says a sub n is equal to 2 to the n plus n. So if I plug in 1 in there, that would be 2 plus 1, which is 3. If I plug a 2 in there, that would be 4 plus 2, which is 6. Plug a 3 in there, that'd be 8 plus 3, which is 11. Plug a 4 in there, that'd be 16 plus 4 is 20. Plug a 5 in there, that'd be 32 plus 5, which would be 37. So there's the first 5 terms of that sequence. And the difference between each one, in this case, is 3, and that is 5. So we can tell right away this is not arithmetic, because it does not have a common difference. So this one says find the nth term of the sequence and then find the 20th term. This is some notation. It's not very clear. So this is telling you, I think it's supposed to imply that this is an arithmetic sequence, otherwise we wouldn't be able to figure this out. And that when they say the first term is 2, and this is saying the common difference is 3. So this means that a sub n would be equal to 2 plus 3 times n minus 1. So if I want to know what the 20th term is, well, that's the nth term, or in other words, the explicit formula. If I want to know what the 20th term is, it would be a sub 20 is equal to 2 plus 3 times 19. So that would be, what, 59? So the 20th term of the sequence would be 59. All right, so there's some examples.